हेलो स्टूडेंट, दिस इज राकेश और आप देख रहे हैं स्पेशलाइज्ड ट्यूटोरियल। आज हम बात करने जा रहे हैं कंप्यूटर ग्राफिक्स में। कंप्यूटर ग्राफिक्स का ऐसे ऑलरेडी हमारे 6-7 एमसीक्यूज आ चुके हैं। सो ये हमारा आज का जो एमसीक्यूज है वो 40 क्वेश्चन का एक एक्सपेंस सॉल्यूशंस क्वेश्चंस है। सो प्लीज़ आप आज हमारा जो टॉपिक है वो लेंदी होगा क्योंकि मे बी इट विल बी टेक अ 1 आवर। So take patience and listen very carefully and try to resolve it at your levels. So in these sections we will be cover computer graphic, definitions of computer graphics, computer generation model, computer graphic model, projections model, conversion, DBST, matrix, 2D, 3D, CRT, LCD, TFT monitors, color and much more. Okay, so let's start the MCQs. So question number 1 is the main hardware component of a graphic workstations. Okay, the main hardware component of a graphic workstations are, so options are display device recorder, input and output device, CPU and display processor, ND, plotter and joysticks. Okay, the main hardware component of a graphic workstations are CPU and display processors. Okay, now move on to question number 2. In random scan display, the display processor has its own instruction set and instructions address register. Hence, it is also called random scan display. Display processors has its own instruction and set and instructions address registers and is also called graphic controller. B. Display processing unit DPU, both AB and D to store processor clock cycles. Okay, so basically it will be the graphic controller and display processor unit DPU. Okay, so both A and B will be the right answer. Now take the next question, question number 3. So question number 3 is in random scan display. In random scan display, what is provided for scan conversion algorithm? Okay, so options are register, local memory, flash memory and no local memory. So no local memory, D is the right answer. Okay, so in random scan display, no local memory is provided for scan conversion algorithm. Now take a question number 4. Frame buffer can implemented using frame buffer. Okay, can implemented using, so options are ROM, B shift register only, C rotating random access semiconductor memory only, and D rotating random access semiconductor memory or shift registers. So first of all we should know about what is a frame buffer. Okay, so a frame buffer basically is a portion of RAM. Okay, it is a portion of RAM and it is a contents a bitmap that device a video display. It is a memory buffer contain a complete frame of data and the information in the buffer typically consists of color value for every pixels and so on the display. So this is the frame buffer. Now move on the questions. So frame buffer can implemented using ROM, shift register, rotating random access semiconductor memory only, and rotating random access semiconductor memory or shift register. So D, frame buffer can implemented using for use rotating random access RAM, as per I just explained the buffer. So RAM, semiconductor memory or shift register. So D is the right answer. Now take a next question, question number 5. What is pixels? Okay, what is pixels? So options are a term of graphic or video display, B a software, C a hardware, D a point. So first I am just explaining here about the pixels. What is pixels? Okay, so pixels basically a picture element. Okay, picture element, and it is a basic unit of the programmable color on a computer display. Okay, and any computer image also. So things of the all logical rather than the physical unit the physical size of pixels depend on how you set the resolution of the display screen. Okay, resolutions like 800 by 600, so it is the depend on the resolution of how many pixels in there. So now questions, so how does the pixel represent? So graphically monitor display picture by dividing the display screen into thousands millions of pixels, okay, and arranging the row and column, okay, and the pixels are so close together, it's a very so close, and they can appear connected, and the number of bits used to represent each pixels determine how many color of shades of gray can be displayed. Okay, so you can't imagine that the how many pixels, 3 pixels are basically the very it's nominal that it screens, and it will be create a picture is very fast. So you will not be just seen at your eyes, because it's a too much fast process to be just flicking the pixels in the screens. Okay, so now to move on the question. So what is a pixels? So pixels is a term of graphics or video display. A is the right answer. Now take a question number 6. So question number 6 is an LCD liquid crystal display, okay, mechanism that uses an individual transistors, okay, to control every pixels in the screen is called what? Passive matrix screen, active matrix screen, both A and B, and none of. Basically an LCD display mechanism uses individual transistor to control every pixels in the screen is called active matrix, okay. And now is a question, so what is active matrix? So basically active matrix known as the film transistor or TFT, okay, film transistors or TFT, and the technology used to flat panel liquid crystal display, okay, flat panel liquid crystal display on notebook, laptop, etc. Okay, so active matrix display provide a more responsive image, okay. Active matrix basically provide a most responsive image as a wider range of view angle at the dual scan, okay. So basically active matrix screen is the LCD display mechanism to use individual transistor to control every pixel in the screen. So question number 6, B is the right answer. Now take the next question, question number 7. So question number 7 is which device is used to specify scalar value? Scalar value. So options are string, B stroke, C locator, and D valuator. Okay, so valuator basically D is the right answer. Now actually what is valuator? So valuator basically is a type of input or graphic system and consisting of a real value, okay, and actual input device that relatively provide input a valuator are dials and radiostats, okay. And now we should know about the what is a scalar value. So scalar value basically a 1 unit of data, okay, it is a 1 unit of data, and this unit of data can be either number or chunk of text, and there are several type of scalar values that all understand. So you know it is scalar value. So now question, which device is used to specify scalar value? So valuators, D is the right answer. Now take on the question number 8. So question number 8 is the smallest size object that can be displayed on a monitor is called. Smallest size object that can display on the monitor is called picture element, point, dot, pitch, aspect ratio, okay. So obviously picture element. What is picture element? So now actually what is dot pitch, and so just defining here the dot pitch. Dot pitch basically something called line pitch, someone say that is strip pitch, and phosphorus pitch, okay. These are the very uncommon name of the dot pitch, like line pitch, strip pitch, and phosphorus pitch. Basically specifications for the computer display, computer printer, image scanner and other pixels based devices that describe the distance, for example between dot means subpixels on the display screen. Okay, now suppose that taking an example of the computer graphics, so it's a relative horizontal and vertical size. Okay, it's a horizontal and vertical size. For taking example, if a graphic has an aspect ratio of 2 and 1, so it means that the width of the twice the largest size and the resize graphic. It's important to maintain the aspect ratio to avoid stitching the graphic out of proportions. Okay, so now move on the questions. The smallest size object that can be displayed on the monitor is called picture element. So now actually I just I know the aspect ratio in the computer graphics relevant horizontal and vertical size. So aspect ratio is basically the 2 and 1, and it means that the width of the twice of the largest file size. So aspect ratio avoid stretching the graphic out of proportions. So dot pitch aspect ratio. Okay, now take a next question. Question number 9. So question number 9 is each screen point is referred to as what? Resolutions, pixels, persistence and dot pitch. So here is the persistence. Okay, so what is persistence? Basically persistence means an object should not be erased unless it is really meant to be deleted. Okay, and the entail proper store and certain measure that allow the data is persist. In term of computer thread and processes, a persist process is one that cannot be killed or shut down. Okay, and this is actually, and suppose that we have to be what is the resolutions and how can. So I will just discuss it later. Now come on the question, is screen point is referred to as? So persistence is the right answer. Okay, now take a question number 10. On a monochromatic monitor, monochromatic means black and white light. Okay, the frame buffer is known as what? Display file, pix map, bitmap and refresh buffer. So what will be? So it will be the basically bitmap. So on a monochromatic monitor, the frame buffer is known as a bitmap. Okay, so C is the right answer. Now take a next question. Question number 11. So question number 11 is on a color monitor, the refresh buffer is called what? Frame buffer, pix map, bitmap and display file. So basically this is a pix map. Okay, pix map is the right answer. You have a curiosity what is a pix map. So basically a pix map stores and display a graphic image as a rectangular array of a pixel color value. Okay, means pix map is a short form of pixel map. Okay, pixel map, and a pix map that use only a single bit to donate to the color of each pixels. Okay, and is often referred to as a bitmap. So now to move on the questions. On a color monitor, the refresh button is also called a pix map. B is the right answer. Now take the next question. Question number 12. So what refer to pixel spacing? Okay, refer to pixel spacing. So options are pix map, pixel depth, persistence and resolutions. So D, resolutions basically refer to pixel spacing. So here is the questions, what is resolutions? So in a computer, resolution is the number of pixels. Okay, earlier questions actually I am discussing about the pixels. Now here is the questions of what is the resolutions. So resolution is the number of the pixels basically in division point of color and content on a display monitor expressed in a term of the number of pixels on the horizontal axis and the number of the vertical axis. The sharpness of an image of a display depend on the resolutions and the size of the monitor. Okay, for example, suppose that we are taking a 1080p. So what is this? Basically full HD HD TV you are taking up from the market, and you suppose that you have any LCDs. This size is the 1920 into 1080 pixels. Okay, also known as the full HD. So HD TV high definition video mode characteristic, but 1080 horizontal line vertical resolutions. Okay, now take a next question, question number 13. So question number 13 is the distance from one pixels to the next pixel is called, one pixels to next pixel is called what? Resolutions, dot pitch, pixmap and PPI. So this is basically a dot pitch. The distance from one pixel to next pixel, it is a dot pitch. Okay, so we actually already discussed regarding the dot pitch, resolutions and pixmap. Now here the unique thing is PPI. Okay, so PPI, what is PPI? PPI, this means the pixel per inch. Okay, pixel per inch, basically pixel per centimeter, ppcm, you can say that. This is the measurement of the pixel density resolutions. Okay, and electronic image device such as computer, monitor, television display and image distillation device, camera, scanners, etc, etc. Okay, so now move on the questions. The distance from one pixel to the next pixel is called dot pitch. So take a next question, question number 14. So question number 14, the maximum number of points that can be displayed without overlap on a CRT. The maximum number of a point that can be displayed without overlap on a CRT, without overlap. Okay, what is aspect ratio, resolution, brightness and pixels. So basically this is a, what is, you tell me, the maximum number of, this is the resolutions. Okay, this is the resolutions. Now take a next question. So next questions, what is the number of point per centimeter, number of point per centimeter that can be plotted horizontally and vertically? What is the number of pointer and per centimeter that can be plotted horizontal and vertically? So options of aspect ratio, pixel depth, resolution and dot pitch. So you know it, actually it's the resolution, the number of point per centimeter that can be plotted horizontal and vertical. So C is the right answer. Now take a next question, question number 15. What, basically what, okay, is the ratio of horizontal point and vertical point necessary to produce equal length line in both directions? Okay, equal length and line in the both directions. So dot pitch, resolutions, aspect ratio, height width ratio. It is the aspect ratio. C is the right answer. Okay, now move on the next questions. So question number 16, identify the odd one out from the following. Okay, odd one out from the following. So frame buffer, pixmap, display program and refresh buffer. What is, so pixmap, basically identify the odd one out from the following is the pixmap. Okay, now take a next question, question number 17. The shortest distance between any two dots the same color is called what? Resolutions, pixel depth, dot pitch and PPI. So it is a dot pitch. C is the right answer. Now take a next question, question number 18. The standard aspect ratio for PC is what? Standard aspect ratio. Okay, so standard aspect ratio is 65, 32, 43, 53. Yes, C 43. Okay, we need basically standard have defined for the, so basically in 2008, okay, so it was the 16 and 9, 169. 16 means that is the 4, okay, 4 proportion 2 and 3 proportion 2. So in the computer industry started to move from 4 and 3 and 16 and 10 to 16 to 9 as a standard aspect ratio for the monitor in laptop. Okay, now take the next question. In CRT cathode use, the electron intensity is adjusted using, okay, what? Accelerating anode, control grid, electron gun, and focusing anode. So basically it is a control grid. Okay, so in CRT the electron intensity is adjusted using control grid. So now the question is, what is control grid and how does it work basically? So control grid is a electrodes using a amplifying thermodynamics value in vacuum tubes such as the triodes and pentodes used to control the flow of electrons from the cathode to the anode, means plate electrodes. Okay, so now basically a cathode route as CRT. Okay, we are just talking about CRT. So CRT is specially vacuum tube in which images are produced when an electronic beam strikes atmosphere surface. So most desktop computer display make use of CRT, and the CRT is a computer display is similar to the picture tube in a television receivers. Okay, so we have just clear so what is CRT and how does it work in a control grid. Okay, so I think, and what the use of basically electron gun. Now let us see electron gun. The most common use of electron gun is cathode rays tube. Okay, cathode rays tube, which were widely used in computer and television monitor. Okay, computer and television monitor. And electron gun can also be used to ionize, the practice of adding or removing electron from an atom. So now the question is, the electron gun, how does it work basically? So electron gun start with a small heater, and which is a lot like the hot, bright and filament of the regular light bulb. It heated a cathode which emit a cloud of electrons. Two anodes turn the cloud into the electron beam, and the accelerating anode attract the electron and accelerated them toward the screen. Okay, now the question is, what is the basically accelerating anode? So accelerating anode basically is the accelerating voltage can be generated with the positively charged metal coated on the in the side of CRT envelope and near the phosphorus screen. Okay, accelerating anode can be used in a fig below. Sometimes electronic gun built in the contain an accelerating anode and focusing system within the same unit. Okay, so we have actually cleared the focusing anode, accelerating anode, control grid, electron gun and CRT. So now move on the questions. In CRT the electron intensity is adjusted using control gun grid, control grid. B is the right answer. Now take the next question. Question number 20. Brightness of a display is controlled by the varying the voltage of the what? So options are focusing anode, connecting pins, grid, control grid and power supply. So brightening the display is controlled by varying a voltage on the control grid. Okay, we already discussed regarding the control grid. Now is the basically actually we already discussed on focusing anode, and you know about the power supply already. So here the connection pin is the new things. What is basically connection pin? That so connection pin basically are anode buttons. Okay, on the CRT is opening near in the back end of the display screen, used to accept the comprehensive lead are the connections, okay, and cathode in electron tubed electrodes, that is the source of current flow. So it is used to connect the lower system, okay. So it is a connection speed. So now move on the question. So brightness of the display is controlled by varying the voltage on the control grid, okay. Now take the question number 21. Lower persistence phosphorus is used in, okay, lower persistence phosphorus is used in animation, simple object, complex object, and all of this. So it's used in animations, okay. Now the questions is basically lower persistence phosphorus, and what is the basically persistence, okay, animations, etc, etc. So let's basically spot of the light produced on the screen by translate the CRT beam energy the phosphorus, and persistent is defined as the time it takes the emit light from the screen to delay 1/10 of its original intensity, okay. Now what is basically animations? So animation is a dynamic medium in which image or object are manipulated to appear a moving image, okay. In a traditional animations, an image is drawn, the painted or the head and transcribed, pseudo seeds and the photographed and exhibited on a film. And now today the most animator are the made within the computer generated image, okay. So now move on the questions. So lower persistence phosphorus is used in the animations. Now take on the next question, question number 23. So question number 23 is higher persistence phosphorus need, okay. Higher persistence phosphorus need what refresh rate? What refresh rate? Lower, higher, medium, and none of these. So basically it's a lower. Now take a next question, question number 24. Higher persistence phosphorus is used in where? Animations, simple object, high complex object, and all of these. So basically it's used in a high complex objects, okay. Now take a next questions, question number 25. Memory area holding the intensity informations of an image. Memory area holding the intensity informations of an image is called what? Refresh buffer, font cache, picture definitions, and video controller. So basically a refresh buffer, okay. Refresh buffer is the right answer. Now take a question number 26. Intensity representations of an image is called. Intensity representation of an image is called what? Frame buffer, picture buffer, and display list, and brightness. So picture definitions, okay. Intensity representation of the image is called a picture definitions. Now what is picture definition basically? So graphic or visual presentations on a surface such as a computer screens, and example like a photography, drawing, graphic design, map, engineering drawings, and any other image. So that a graphic often combine text and illustrations. So this is the basically a picture definitions, okay. So now move on the question. So intensity representation of an image is called picture definitions. Now take the next questions. Question number 27. The purpose of refreshing FCRT is, okay, to avoid flickering, to maintain steady picture, to avoid fading of pixels, and all of above. So basically the purpose of refreshing CRT to avoid flickering, to maintain steady picture, to avoid fading of pixels. Basically all of above is the right answer, okay. Now take a next question, question number 28. The flyback of electron beam. Flyback of electron beam from one scan line to next is known as what? Vertical retrace, horizontal retrace, reverse scanning, and refreshing. Okay, so basically it is a horizontal retrace. What is horizontal retrace? So now horizontal retrace basically electron beam and a raster scan display. An electron beam returns to the left of the screen. Where? Left of the screen after refreshing each scan line, and it is called a horizontal retrace of the electronic beam. Some system has multiple bit per pixels in the frame buffer is often referred to as pixel. Now what is basically vertical retrace? So vertical retrace, this is the alternative reference of the blanket intervals and the vertical synchronized signals, and vertical retrace is a measurement of the time related to the video display. It represents the amount of the time between the end of one frame being drawn and the beginning of the next frame. Okay, so it's clear what is a horizontal retrace and what is vertical retrace. Now focus on the questions. The flyback of the electron beam from one scaling in next to known as a horizontal retrace. So take a next question, question number 29. So question number 29 is the return of electron beam. Return of electron beam the top left corner of the screen after one frame is called horizontal flyback, vertical flyback, scanning, and none of above. So basically it is a vertical flyback. Okay, now take a question number 30. In a raster scan display, the frame buffer hold what? Line drawing commands, scanning instructions, image resolutions, and intensity informations. Okay, so basically in a raster scan display, the frame buffer hold intensity information. D is the right answer. Okay, now here is the question, what is intensities? The angle at which light from a point light source hit an object in a functions of the positions of the both the object and the light source. The intensity of the light source hitting the object is a functions of the distance between them. Okay, now take the next questions. Question number 31. So in random scan display, the frame buffer hold. Random scan display, the frame buffer hold. So options are line drawing command, scanning instructions, image resolutions, and intensity informations. So here will be the right answer, line drawing command. Okay, now take the next question. Identify the odd one out from the following. Okay, vector display, raster scan display, calligraphic display, and stroke writing display. So here is the B, raster scan display. Okay, now take a next question. So question number 33. Okay, so question number 33 is interlaced refresh procedure is allowed in. Okay, interlaced refresh procedure is allowed in LCD, DVST, raster scan display, and random scan display. So basically it is allowed in the RSD, raster scan display. Okay, the interlaced refresh procedure is allowed in the raster scan display. Okay, now here basically we can say that the LCD. So we already told about the full form of the LCD, liquid crystal display. Now defining something. LCD basically a liquid crystal display is a technology used for display in a notebook and other similar computer like light emitter diode. It's used in the LED and gas plasma technology. Okay, LCDs allow display to much thinner than cathode ray tubes technology. Okay, clear? Now take a next question. Question number 34. Vector display is well suited for. Vector display is well suited for line drawing applications, animations, cartoon, and all of this. Basically vector display used for the line drawing applications. Okay, not for the animation, cartoon. So A is the right answer. Now take the next question. Question number 35. So 35 question is a beam penetrations method. Okay, beam penetrations method is usually used in where? LCD, raster scan display, random scan display, and DVST. So random scan display C is the right answer. Beam penetration method is usually used in random scan display. Okay, now take a question number 36. Shadow mask method. Shadow mask method is usually used in LCD, raster scan display, and random scan display, and DVST. So it is also use raster scan display. Okay, beam penetration method, random scan display, and shadow mask method, raster scan display. Very confusing questions, so be questions like this questions will become. So shadow mask, raster scan, okay, and the beam penetration method, random scan. Okay, raster random, don't confuse like this. Okay, now take a next question. Question number 37. Identify the color produced in beam penetration method. Identify the color produced in beam penetration. Red, green, blue, white, red, orange, yellowish, green, red, green, blue, green, red, white, orange. Okay, so basically red, orange, yellow, green, this is the right answer. Now actually beam penetration method. Okay, some describe the beam penetration method. What is? So color CRT monitor, the beam penetration method for displaying color picture has been used with random scan monitor. Okay, two layers of phosphorus, usually red and green, are put on the inside of the CRT screen, and the display color depends on how far the electron beam penetrations into a phosphorus layer. Okay, so question number 38. An RGB color system, red, green, blue. Okay, so 24 bits as a storage per pixel is known as what? 24 bits. Okay, so 24 bit. So color CRT, true color system, RGB monitor, and color depth. So B, true color system. Okay, true color system. Now actually what is true color system? So true color is specifications of the color of pixels on a display. Okay, listen carefully. True color is a specifications of the color of pixels on a display screen using 24-bit value, which allow the possibilities up to the 16777. Okay, in the possible color. Okay, and the some new color display system offer a 32-bit color mode. The extra byte called the alpha channel and is used to control and special effect informations. Okay, now true color image. What is true color image? So true color may refer to true color. Okay, and the rendering the object natural color through an image. True color uses a 24-bit color depth of display and an RGB image. True color, a scale used determine the color of water after all suspended material has been filtered out. Okay, now question. So what is the true color of water? Okay, so while relatively small quantities of water appear on the colorless, so pure water has a slight blue color that become a deeper blue as the thickness of the observed sample increase, and a blue hue of water in a intrinsics properly, and the cause of selective absorption of the scattering of the white light. So what does the basically 32-bit color means? 32 bits, 24 bits. So 24 bits usually means the 24-bit total per pixels, with 8 bit per channel for red, green, and blue. So 16,77,007. Okay, like something total color will be approximately 16. Okay, 1,67,17,216. Basically it is a total color of 24 bits, and it is sometimes referred as the 24 bits RGB. It's the 32 bits usually means 32 bits total per pixels, means 8 bit per channel. So additionally 8 bit alpha channel that use data transparency. Now the questions 256 colors. How many bits? Each 256 colors. So there are two forms of 8-bit color graphic. The most common, use a separate palette of 256 colors, and where each of the 256 entries in a plates map given the red, green and blue values. The most color map, each color is usually chosen from the palettes. So 16,77,000 basically. It's a color of 24 bits, 8 red, 8 green and 8 blue. So clear? So and now move on to questions. So an RGB color system with 24 bits as storage per pixels is known as a true color system. So now take the next question. Question number 39, the second last of the question of this MCQ. So identify the features of vector display. Identify the features of vector display. High resolution, jagged line, lagged in the color depth. Smooth line, poor resolution, black and white. High resolution, lack in color depth, smooth line, and inexpensive, monochromatic and smooth line. So basically identify the features of vector display is the high resolution, jagged line and lack in the color depth. Here is the right answer. Now take a last question of this MCQ. Question number 40. Identify differences type of computer graphic. Different type of computer graphic. So options are monochrome and color, CRT and flat panel, vector and raster, and monitor and hard copy device. So basically see vector and raster. So here is actually flat panel. Flat panel monitor. We already discussed about the CRT. So now what is a flat panel? Basically flat panel display is a CRT monitor, and flat panel display is a liquid crystal LCD like this. And it is a light emitted diode technology, make them much lighter and thinner compared to the traditional CRT monitors. So differences between the flat panel display in a television monitor and other display appliances that uses a thin panel design instead of a traditional cathode ray tube like a CRT design, and these screens are much lighter and thinner and can be much more portable and traditional television and monitors. So aspirants, I hope you enjoyed our MCQs. So thanks for watching video. So please like, subscribe and share it.